about how you can use noise in your sketch. There are two different ways that you can use it. Like basically, it's just a matter of how you prefer to organize it. One way is you create a variable and you have it equal this little algorithm, this formula, noise, with an argument of n, for example, times a number. And you use that variable in your shape and just make sure that you are incrementing n outside it. And of course, up at the top, you would have had to initialize and declare a variable named n, and that can equal whatever, 0 or 1 or whatever. It doesn't matter what it equals. This is like the neater way. Another way you can do is to take this formula and place that directly in the shape. So essentially you're taking out this step here of having a variable equal it, and you're just using the formula directly in it. The end result, and it's totally fine if you want to do it this way, is just that your shapes will be a lot longer. So you can see in this one line, I just have x, 0, x height, and in this one it's line, noise, n times width is all the same as in this one doing x, because that equals this. You can do it either way. All right, so if you follow along on the PowerPoint, I have like a first practice. I'd like you guys just to go ahead and do that on your own. And then I'm going to jump ahead to here, where I've already given you the code for how you can take your lines and then rotate them and translate them so it looks like a spiral. And I'm going to pick up from here and just talk you through, although you have it there on the PowerPoint, but talk you through adding the noise. All right, so just make sure I have the right sketch. Yes, this is the right sketch. Okay, so either way that I'm going to do it, I need to have a variable up at the top. So I can have float n equals 0, for example. So I have that variable. So let's do it the replace way first. So I'm going to take out x, and instead I'm going to have it equal noise with variable n as an argument times, I'll say times 300. All right, and I'll just do it in one spot. And then outside my while loop, so it's very important that it's outside the while loop, I'm going to do the increasing of n, not inside the while loop. So n equals n plus 0.002, for example, a small number. Okay, so let's play this. And I'm getting this movement. I need to have like a fading rectangle or else you can't really see it. Or I could just put an opacity on my stroke or something like that. But I'll do the fading rectangle. So you can pause and do the same. Okay. Oh, I need to have my this. Make that white. Is it gonna work now? Yes. Okay. And so now that's working. And I just added noise to one of the coordinates, to my x coordinate. I could, so it's hard to tell because it's on a rotation, but it's really just the x that is moving. And that's kind of cool. So remember the things that you could adjust. If you could adjust this number, and you can adjust this number. If I make this any smaller, I'm probably not going to really notice the movement. I could add another 0. It's going to be very subtle movement now. You see how it's just tiny bits moving. So go in the other direction, and I'll make it go a little bit faster. So now it's a little faster. All right, so while that's playing, let's just go over this again. So what I did this time was I made a variable up at the top, had it I called it n, and I have it equal 0. It can equal whatever, doesn't matter. And then in my shape, I use that little algorithm, noise argument n times 200. Outside of my while loop, I increase n by a very small number. All right. So that's one way to do it. Let's just see if I did this on another coordinate as well. I'll do it on an outside coordinate. See what that ends up giving me. So there's just more movement now, that's all. But you could replace just one coordinate with noise or multiple. Just play and experiment. Experiment with the number that you multiply noise by, this number, the coordinates that you replace, and the numbers that you increase n by outside of the while loop. All right, now let's do this the other way. And so this is what we just did in the PowerPoint. This is where we are, where we replaced it. And this time I'm going to have, back to my sketch here. Instead, I'm going to do this in the draw right after the variable that I use in my while loop. And it's going to be, I'll call it I, because like I is not something I'm already associating with X or Y coordinates. And I'm going to have it equal this little formula here. So I could just cut that out. Put my semicolon, and I'll put I in its place. And the same thing over here. I'll put I in its place. All right, so I is equaling that formula, and in my line, I just use the variable. And I get the same results. I mean, every time you play a sketch with noise, it will give you something different because it is a random number generator, but it's generally the same results. So you can do it either way, whichever one that you want that makes more sense to you. All right, let's go to something that would be more like the mandala. Okay, so this is where I left off with the rotation example. I just took the rotate out now, so we can start with a static one. And so up at the top, float n, and I'll have that equal 0. And I prefer the method of having a variable equal my formula. So I'll do float I equals noise n times 200, close it out. And now I'm going to use I in my shape. So maybe I'll replace this X with I, for example. And now outside of my while loop, so here's the open bracket for my while loop, here's the closing bracket. Outside of it is where I increase n. N equals n plus 0.002 I can use as a starting point. Okay, and so now you can see that this inner circle is moving. I still have the mouse X and mouse Y on the fill for those shapes. And if I want to see it move faster, I could increase this number, or I can also increase this number, and that gives it a larger range of numbers. So yeah, so now it actually started out really quite large. That's because I increased the 200 to 300. That's triggering that. So this number up here triggers like how physically large it'll be on the canvas, and this number triggers how fast it'll be. Okay, so you can just kind of keep tweaking those numbers until you get something you like. You could try noise in other things. Right now I'm just giving you examples of doing it in one spot. You could try noise on a width and a height. And that might need a number added to it, I'm not sure. You could try it in a fill, you can try it on the Y, you can try it in the rotation, you know, all different kinds of places. I'm going to add a low opacity on this so we can see if we're getting some kind of cool effect here. So it's changing, now it's moving, and it's actually physically changing the size. So there's a lot that's happening. It's hard to tell exactly what it is. But so you can, like, I think that's what I like about this method is once you have it, a variable that equals this, you can just start plopping that variable into different spots. So, you know, put it into the width, put it into the height, put it into the fill. Let's try that. I'll put it into the fill here. Instead of having it as mouse X, let's use the variable I. See what that will give us. Okay, so it's subtly changing. You know, I might need to increase I times something, for example. I times, I'll say 10. See if that gives us a wider range of numbers. Well, you can keep, you know, tweaking with these things, and you get the general idea of basically you can, just like random, plop into anything that takes a number, and now it's just a matter of how you want to tweak those numbers and play with it. All right, have fun. Let me know if you have any questions.